Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome you all to video lecture. Today's topic is resolution of vectors. Learning objectives. By the end of this lesson, you will understand how a vector can be split into perpendicular components using trigonometry, and we will also solve some example problems. What is vector? A vector is a quantity with both magnitude and direction. Examples are displacement, velocity, force. Basically, a vector is represented by a bold letter or a letter with an arrowhead above. We have already studied about the vector addition. Now we will recall it again. A vector is a quantity that has both magnitude and direction. In the figures, you can see that the line is representing the magnitude as we are given with the two lines here, A and B. These both are vectors. The length of the line will give you the magnitude and the arrowhead will give you the direction. Similarly, when we will be adding the vectors, we will use a rule which is called as head to tail rule. So for adding the vectors, head to tail rule will give the resultant vector. In the figures 3, you can see that head of the first vector is joining with the tail of the second one, and as a result, what will happen? The resultant vector is starting from the origin and joining with the head of the last vector, and arrow is directed towards the last vector. So the length of the line will be the resultant vector and its direction is always towards the last vector. So that is how we can add two or more vectors. Resolution of vectors. As we have already observed that two or more vectors are added by head to tail rule. Similarly, when we have to resolve the vectors, it means that we have to break them up or we have to split them up. So basically the reverse process of head to tail rule is also possible, that is, given vector can be divided into two or more parts. These parts are called the components of the given vector. To divide the force into components is known as resolution of force. So as you can see in the figure, this is the applied force from the head of the one vector, resultant vector or the given vector. We have drawn another vector which is parallel to y-axis, and from the base of that we have drawn another vector which is parallel to x-axis, that is why we have got the two component of forces, one the y component of vector f and the other one is x component of vector f. As this is horizontally acting, so this will be known as horizontal component of vector force, and as it is parallel to y-axis, that is why it will be known as y component of vector force. Now, resolving a force into its component, let us see that how trigonometric ratios are doing their work. What are trigonometric ratios, or what is trigonometry? Basically, trigonometry is a branch of mathematics in which we discuss about the relationship, or we discuss about the right angle triangle. As you can see, this is a right angle triangle and we have got three sides: base, perpendicular and hypotenuse. The ratios are opposite means perpendicular basically. Opposite over hypotenuse is known as sine theta. Adjacent over hypotenuse, adjacent is also known as base. Adjacent over hypotenuse is equals to the cos theta, and opposite over adjacent means perpendicular over base is called as tangent theta or tan theta. When we talk about the vertical components or perpendicular components like parallel to y-axis, it will be f sine theta, as we know that it is perpendicular over hypotenuse. As the relationship is between the perpendicular axis and the hypotenuse, or the base one will be the adjacent and the hypotenuse, so it will be related to the f cos theta. So along y-axis it will be f sin theta, and along x-axis it will be cos theta. So why resolve a vector? Many problems become easier when vectors are split into perpendicular components. Usually, obviously I have already told you that usually we take it as horizontal and vertical. Now we are going to discuss the resolution of force in detail. We have got a figure here. Again, what we have done, when a force is resolved into two components which are perpendicular to each other, these are called its perpendicular or rectangular components of force. Let us now resolve a force F. As I have already discussed these things, we are going to discuss them again with the detail now. We have got this force F. Now we are going to divide them into their two perpendicular components, or split them into two perpendicular components. A force F acting on a body at an angle theta. You can see this angle is called as angle theta with x-axis. We can see in the figure as well. Imagine a beam of light placed above the vector F. As the light falls perpendicular to the x-axis, it will cast a shadow OA of vector F onto x-axis. We call this shadow as x component of vector F. In the same way, if light is throwing perpendicular to y-axis, the shadow OB, this is shadow OB of vector F on y-axis, is the y component of vector F. A component of vector is the effective value in a given direction. So, with the help of this figure, you can see that how the components of force F are taken. Now, making use of trigonometric ratio, we can find, as we have already seen through the figures. Now again we will see that horizontal component Fx and vertical component Fy. Cos theta is equals to OA over OC. That is what? Again, base over hypotenuse, and through the trigonometric ratio we know that cos theta is equals to OA over OC. So here we have got Fx over F here, and by giving it a form of formula or equation, we will get Fx means x component of force F is equals to F cos theta. Similarly, sin theta is equals to AC over OC. Here, perpendicular AC over OC. Perpendicular over hypotenuse means sin theta. So, y component of force F will be equal to Fy is equals to F sin theta. Note that the resolving forces is used to find how much of the force acts in a certain direction. Now let's discuss about the solving example, that which kind of questions will be there for your numerical problems, or how you will be able to solve them. Resolve a force F is equals to 60 Newton, making an angle of 40 degrees with the x-axis. What we are given with? The force, the resultant force, the angle. What we have to find out? We have to find out the y component of force F and x component of force F. So, sine 40 is equals to F vertical divided by 60 newtons. Putting the values, what we will get? The answer will be 38.6 Newton. Similarly, cos 40 is equals to F horizontal divided by 60 Newton, as we are given with the 60 Newton. By calculations, we'll get the answer, that is 45.9 Newton. So that is how we can find out the values for the components of force. Now let's have a quick quiz. What is meant by the resolution of force? Adding multiple forces together to find a single resultant force. B question is breaking down a single force into its component forces, measuring the magnitude and the direction of force, applying a force to an object. The answer is breaking down a single force into its component force. The statement was, what is meant by resolution of force? So out of all these options, what is the correct one? The B one, breaking down a single force into its component forces. Question number 2 is, when resolving a force into its rectangular components, what is the angle between these components? Options are 30 degrees, 45 degrees, 60 degrees and 90 degrees. The correct option is 90 degrees. How you will get the answer? When resolving a force into its rectangular force, what is the angle between the components? As we have already discussed before, that these components will be perpendicular to each other. Perpendicular means that the angle between them will be 90 degrees. Question number 3 is, what is the formula for the horizontal component of force making an angle theta with the horizontal? F sine theta, F cos theta, F over sine theta and F over cos theta. So horizontal components, when we talk about the horizontal components, so it will be base over hypotenuse. So we will get the correct option to be F cos theta. It will be Fx cos theta.